Hi guys, welcome back to my channel, and in this video I will teach you how to run this 220 volts motor from a washing machine at just 12 volts DC. So guys, this is the inside view of the motor. You can see the copper windings inside. Okay, and now I'm going to rotate the shaft. Yeah, the moving part is the armature, of course, and the other one, this one is the field winding, one this side and the other one is this side. Now although this motor was manufactured in 2003, but it is still in good condition and working really good. And you can see that these are the bearings. It is not on bushes but on bearings. Now you can see that there is a good high quality base provided to this motor here to this side and to the other side. And you can see here that there are a lot of wires for connecting this motor to the power supply, and hence making it really difficult to understand the wiring for running it on 12 volts. Now another thing about this motor is you can see that there is the commutator, and that commutator means that it is a brushed universal motor, so it can run both on AC and DC. Now on close inspection you can see that this is the red wire, right? This is connected to one of the brushes, and on the other side blue wire is connected to this brush, and all of them are coming out here to this socket. IFB Industries Limited universal motor, 50 mm stack. Although the power rating is not visible anymore, but still it's showing that it is single phase 230 volts 50 hertz and manufactured in 2003. Its power rating, as I have seen on other motor tags, is 693 watts. Now the pins of all these wires are coming out here, as you can see, 6 pins. Okay, so anyways guys, let's start with the connections part. First thing to be understood about this motor is that the rotating part, as you see here, is the armature, of course, and the other winding is one of the field poles. Now comes the other field pole. This is the other field pole. So in total there are 2 field poles, of course. Now these 2 field poles are together connected in series, and the final 2 wire output coming out from both of these poles is through this yellow wire coming out with this black and white wire. Okay, so both the lower pins are for the field output, and the blue and the red wire, as I told you, are coming out from the brushes, and these 2 yellow wires are from this part, which is not important for the 12 volts connection point of view. Okay, so we have to neglect the upper 2 yellow pins, and all we need are these 4 wires: red, blue, black and white. So the upper 2 will be neglected, middle one are this and this, and lower are this and this, which are the only ones necessary for wiring the machine in 12 volts DC mode. Okay, so guys, since these 2 lower ones are for the field poles and the middle ones are for the brushes or the commutator feeding the armature windings, these two cannot be connected together. Like this one and this one cannot be connected or short circuited together, neither can these 2. So what we have to do is connect the armature of this motor in series with the field. Okay, so for that I'm going to use jumper cable, although we are not going to need this wire. Okay, so what I will do is I will connect one terminal of this wire to the left hand terminal, like this one, left lower terminal. Okay, and the other to the left of the middle 2 terminals. Now what we are left with are 2 terminals, this one and the lower one, and these 2 are not needed, as I said before. What I'm going to do is connect one wire to the lower to the lower terminal, and the other blue wire to the right middle terminal. Okay, now with that being done, we are left out with only two wires, this and this. Okay, so guys, the wiring is complete. Now let's test it with this 12 volts 70Ah battery. So I will connect this wire afterwards. First I'm going to connect this wire to the negative. You can see that it is running at a really good speed. Yeah, the speed is good. The torque is also good, and the RPM is very high. So guys, the setup is working. Let's do some close inspection while it's working. Yeah, you can see the RPM and the armature flow reading inside. RPM is really good. Also, you can see that there is no other wire given, and the connections are like this. Okay, so guys, let's turn it off now. So this is how this 220 volts motor is going to work if the connections are done properly. Let's increase the input voltage to this motor and see how much RPM I can obtain. So guys, there is one thing that I forgot to tell you is that if we interchange the polarity, what happens? Okay, one terminal is connected like this and the other one is like this. Yeah, the rotation is clockwise, and if we interchange it, still the rotation is clockwise. This is why it is said that universal motors don't change their direction of rotation. Okay, now the higher speed part by giving it an even higher voltage up to 60 volts from an e-bike battery charger. Okay, so this is the pinout from the e-bike battery charger. Now the voltage is 5 times higher than the 12 volts battery, so obviously the RPM is going to be really high. Okay, go. Yeah, it is really dangerous now. Yeah, still rotating, and the RPM was really high. Let's do it once again. Yeah, the RPM is very high at present. Must be around 7,000 or 8,000 RPM. So yeah, this is what happens when you connect it to very high voltage supply. As I told you in my previous video that a universal motor can run only in one direction, which is clockwise, and not in anti-clockwise direction. So still, if we want to run this universal motor in both clockwise and anti-clockwise direction, what we will have to do is we will have to convert this universal motor into a DC shunt motor. Now to run this motor in both clockwise and anti-clockwise direction, all we have to do is change the connections over here and nothing else. The lower pins are from the field winding of this universal motor. This winding, the upper one, this one is the armature, this is the field winding, and this one is also the field winding. So the two lower pins are from the field winding. So to these field winding I will connect two yellow cables. Okay, yeah, this one and this one. So the two yellow cables have been connected to the lower pins. Now to the two middle pins, which are connecting the brushes or commutator feeding the armature winding, this one, to these two pins I will connect these two wires. Okay, so guys, the connections have been successfully made. These two are from the brushes or the armature winding, and the two yellow ones are from the field winding of this motor. Okay, now comes the connecting part. How we are going to connect the batteries to run it in both clockwise and anti-clockwise direction. So guys, first I'm going to show you the resistance of the field winding and the armature winding. Okay, so 200 ohms resistance mode. Let's bring the pointer to that. So yeah, it's at 200 mode. Okay, so first checking the resistance of the field winding of this universal motor. Now the two yellow wires are for the field winding of this universal motor. So connecting the multimeter pins to the yellow wires, and you can see that the resistance of the field winding of this universal motor is very low. It's 2 ohms, almost only 2 ohms. So the field draws huge amount of current. Very thick winding has been used for the field winding of the universal motor. Now let's measure the resistance of the armature winding of this universal motor. So this orange and this blue colored wire is for the armature winding. Let's measure it. You can see that its resistance is 4.5 ohms, and there is this case with the universal motor that higher the RPM at which this universal motor is operating, higher will be the resistance of the armature winding. Let's see. You can see I rotated it. Its RPM increased from 0 to some value, and the resistance increased from 4 to 10 ohms. Let's go a bit further. You saw it 12, 18, 23. I'll try and go a little bit more. 24, 35, 46. So guys, what we can conclude from this experiment is that the resistance of the field winding of a universal motor remains constant, and it does not depend on the RPM at which the universal motor is running. But the resistance of the armature winding changes with the change in RPM of the universal motor. Okay, now comes the battery connection part. So guys, for powering up this motor as a DC shunt motor, I'm going to use this 12 volts 7Ah battery, and I'm going to use two of these first. One for the field and the other one for the armature winding. So guys, I've connected one of the armature wires to the negative Now I'm left with this orange one which will be connected over here to the positive. But before I activate the armature wire, first I will connect the field wire. Okay, so for the first case, yeah, shorter one I should connect over here, a little short. Let's move the batteries closer. Yeah, just enough. So yeah, one of the field wire has also been connected. Now I'm left with only two wires, one from the field and other from the armature. And now the field will draw huge amount of current, and since it's a coil, it's gonna charge itself like an inductor and there will be spark. That spark is because of the inductance effect from the field of this universal motor. So let's start it and see in what direction it runs. Okay, go. So yeah, it rotated in the anti-clockwise direction. Look closely once again. Okay, keep watching the armature shaft. Okay, go. Yeah, in the anti-clockwise. Now I will interchange one of the polarity, like I'm going to interchange the poles for the armature. Okay, not the field but the armature, only the armature. Okay, one wire has been connected. Now let's see if it rotates now in the clockwise direction. Okay, go. Yeah, you can see that now it rotated in the clockwise direction because I interchanged the polarities of the armature poles. Same effect will happen if we keep the armature poles same but interchange the field poles. So guys, what we conclude from this test is changing one set of poles, either of the armature or of the field, changes the direction of rotation for the shaft of a universal motor. Now let's do the same test with one single battery. Okay, so when running this motor in both clockwise and anti-clockwise with just single battery, what we will have to do is connect the armature winding in parallel with the field winding, and for bidirectional rotation like clockwise and anti-clockwise, we will have to interchange the polarity of one set of the poles, as I said. Okay, so the longer wire from the field I will connect to the orange wire. Okay, now let's see in which direction this shaft rotates. And while doing this test, even with the 12-volt battery, don't touch these wires with bare hands, because there is going to be inductive effect and the voltage is going to fly back and electrocute you. Okay, go. Yeah, you saw that it rotated in clockwise direction. Now let's interchange the polarity. The longer wire has been connected to the orange one. Now I will disconnect it and connect the shorter wire to the orange one. Okay, let's remove it from here, it's unsafe. Okay, so the shorter wire now has been connected to the orange one and the longer wire will be connected to this blue wire. Okay, let's try that, and it should run in anti-clockwise now. Okay, go. Yeah, you saw that it rotated in anti-clockwise direction. Now you must be noticing that I am just touching it for a second and removing it. That is because the batteries are drained and it's only a 7Ah battery, and this motor in the shunt connection is drawing huge amount of current from this battery and is draining it a lot. So for that reason I'm connecting and disconnecting it. Okay, let's try once more in the anti-clockwise direction. Okay, yeah, so it's working with just a single battery as well. And remember one thing guys, when using this motor, universal motor, as a DC shunt motor, the RPM is going to be very low, but the torque for this motor is going to be very high because the field will be powered directly. So it is going to create a strong electromagnetism inside and thus giving it a very high torque. Okay, so guys, the 6 pins that you see here, these 6 pins are responsible for running this universal motor in every mode possible, like as a universal motor, as a DC shunt motor, and both in clockwise or in anti-clockwise direction. Only these 6 pins are needed, and not even these 6, the upper 2 are neglected because they are for counting the RPM of the motor. So only the 4 pins, the middle 2 and the 2 below it, are needed for running this motor in every possible mode. So guys, the lower 2 pins are for the field winding of this motor. The upper one is the field winding and the lower one is the field winding, and the one rotating is the armature. So this and this are the field windings which are getting their connection with the lower 2 pins, while the 2 middle pins, this and this, the 2 middle pins are for the armature winding. Now to the lower 2 pins I will connect these 2 yellow and orange wires. Okay, so let's do that. Now I am left with the 2 middle pins for the armature winding. Now for the armature winding I will connect these 2 wires, black and red. I will connect red on this side and black on this side. The armature winding is also connected and the field winding is also connected. Now to use this motor as a generator, I will power up the field winding by giving it some amount of voltage, like 2 to 12 volts DC. And yes, I will be giving DC to the field winding to create constant poles. Like if this is north, then this is south. Okay, so sorry, the poles are here and here. So if this is north, then this should be south and at constant. And the generated electricity will be extracted from the armature winding. Now remember guys, this red and black wire, these 2 wires are connected to the armature winding and the one below it are connected to the field winding. So power supply will be given to the field winding, which means to the yellow and orange wires, and electricity will be generated and will appear on this red and black wire. Okay, so guys, to excite the field winding, I will be using this 3.7 volts lithium ion battery cell. Okay, so let's measure its voltage first. So guys, as you can see that it is pointing 3.7 volts almost, so it is charged, I would say. So this will power up the field winding of this universal motor, which in turn will generate electricity on the armature wires when this shaft will be rotated. So to connect this battery to the field winding, I will use 2 neodymium magnets. Yeah, one for this side and the other one is for this side. And 2 nails. Okay, so guys, it's time to power up the field. We'll connect this to this side. The negative has been connected, and as soon as I will connect the positive, the electric current will start flowing through the field winding. Okay, so now I'm going to connect these wires, black to the black and red to the red. Okay. Okay, so guys, the output, which means the armature winding, has been connected through these pins and through these wires to the multimeter, and when I will rotate this shaft, you will see some voltage reflected on the display screen. Now at present I am rotating it, but no voltage is being displayed. That is because the field is not yet excited. Okay, so let's do that. Okay, go. Yeah, you saw that voltage was only 0.15 volts. Now guys, I'm going to replace the input power supply with this 12 volts 7Ah UPS battery. Okay, and then measure the generated voltage. Okay, so guys, now when I will rotate this shaft, you should see some more voltage generated and reflected on the multimeter screen. Okay, so keep watching it guys. Okay, yeah, now initially it was only 0.15 volts, but now the hand rotation voltage increased from 0.15 to almost 7 to 8 volts DC. Now let's do some rope testing. Moving the voltage pointer towards 200 volts DC mode. Okay. Yeah. Guys, as you saw that the voltage was almost 75 volts DC. Now let's connect some actual load to it. Okay, so guys, now I'm going to use this 100 watts incandescent bulb, 220 volts, 100 volts. Now the voltage is low, that is 75 volts, that was obtained from the rope rotation test. So I'm not going to get full illuminance, but it would be enough to show you the demonstration. Okay. Okay, so guys, the wires have been connected. Now all I'm left with is this wire and the rope. Now let's wound the rope first. Okay, connecting the wire. Wire has been connected. Okay, go. Oops. Bad timing, and the wire got out. Once more. Yeah. Okay, so guys, I have turned off the lights to show the proper illuminance of this 100 watts bulb. So let's see it now. Okay, so connecting this wire. Okay. Yeah. So guys, as you saw that when this universal motor from washing machine is used as a generator, it can glow this bulb. Now although the illuminance was not very high, because this motor is rated at very high RPM, which is around 11,000 RPM, and the rope rotation RPM was not that high. So at higher RPM it will produce more voltage, even higher than 250 volts perhaps, and the power rating when this motor is used as a generator will be same, which is 600 watts. Okay, so guys, that would be all about today's video. Thank you so much for watching it. Please hit like and don't forget to share and subscribe, and if you have any queries you can always ask them in comments. Thank you.